our previous example, if when the quadratic function is written into this form, a times a parenthesis x minus some number square plus another number. Now this form is what we call the standard form of a quadratic function. Here, a is any real number except 0, and the h and the k, they can be any real number. Now the good thing for using this form to express a quadratic function is from this number h and k, we can tell the vertex. So the vertex is the point where the x coordinate is h and the y coordinate is k. So for example, if I'm given this equation, fx equals 3 times x minus 1 square plus 2. So from this equation, what I can tell is, okay, first, this is a quadratic function, so the graph is going to be a parabola. And secondly, I can tell the vertex is the point 1 and 2. Okay, now let me do a second example. Now, so in this case, some student, they would think, okay, the vertex is a point 1 and 7. Now, actually, this is not right. This is not right. Because if we compare this function with the standard form, you will see the h is number after the minus sign. Okay, h is the number after the minus sign. And k is any number after this square. So in this case, the vertex is -1 and -7. Well, if we rewrite this given function and write it exactly into this form, you will see it will be -4 times x minus -1 square plus -7. So you can see here h is a -1 and k is -7. Okay, now the way I teach my student to remember this is when you are given, when the equation you are given is in the standard form, and you are looking for the vertex. So the way we find the h and k is you take a look at what do we have in the parentheses, and you think about what is the solution of this expression when this expression equals 0. Okay, in other words, you think about which number will make this expression be 0. So when x equals -1, this expression will be 0. So that number -1 gonna be the h. And every number after the square gonna be the k. So that's why here the vertex is a -1 and a -7. Okay. Now let's take a look at another example. fx equals x plus 2 square. Now in this example, the h is a -2 because -2 will make this expression x plus 2 be 0. And what about k? Now because we don't have anything after the square, so that means the k is 0. So in this case, the vertex is the point -2 and 0. Okay, good. Now we can tell when the equation is given in the standard form, we can tell what is the vertex. And then how can we tell if the graph opens up or opens down? Now actually we can tell this by looking at the value of a. by looking at this value. Okay. If this number A is a positive number, then the graph opens up. And if A is a negative number, the graph opens down. So using this way, we can tell, okay, for this quadratic function, even though right now we don't know where is the vertex, but we can tell since A is positive 3, so the graph opens up. And here, since A is negative 7, so the graph opens down. And here, A is negative 1/2, so it opens down. And here, A is positive 2. Now, please keep in mind, so in both ways, no matter the quadratic function is given into this form or in this form, the A is always the same. So here A is positive 2, right? You see here A is positive 2, and when we convert this form into this way, so A is also positive 2. So A is because A is positive, so the graph opens up. Now here, because A is a positive 3, so it opens up. And here A is a negative 4, so the graph opens down. Now down to here, so the A is 1. Remember, the A is 1, but we used to not write the 1, right? When the coefficient is 1, we used to not write it. Therefore, the graph opens up. Okay, now in this video, we saw that when the equation is given into a standard form, we have a way to convert the equation into this general form, ax squared plus bx plus c, right? Just like what I was doing here. Now in the next video, I will show you what if the equation we are given is in the general form and how to convert it into the standard form. Because we said if the equation is written in the standard form, the best thing is that we can find what is the vertex, right?